If you've ever gotten stuck thinking about event propagation, then this video is definitely for you. Hello and welcome to Conscious Web Dev, where we pause to think before we code. Before we get into this video, there are a couple of things that I assume that you are familiar with. Basic HTML, basic CSS, basic JavaScript, as well as a basic understanding of the so-called DOM, and in this particular case, how to interact with elements by querying them, and lastly, how to react to an event via the add event listener function. And full disclaimer is that nothing I talk about here will be based on technologies like frameworks and libraries that you might know. Instead, everything will be based on vanilla web development practices and technologies, meaning what's baked into the browser, and that is HTML, JavaScript, and CSS. Let's get started. For every time an event is fired in a browser, you will find what is called a target. And the target is the element for which the event was fired. It's the element to blame for the event being fired. And depending on the event type that you are working with, be it click-related events, key-related events, submit, focus or blur, or lastly scroll, you can see that the assignment of the target itself, highlighted in red, is completely dependent on the actual event type that you are working with. And we will proceed by talking about the click event type, but mind you, what I'm discussing here is applicable to most, if not all, events that you will find. If we start by looking at an empty web page, you will find this 4P structure. You will have the window, the document, the HTML or document element, and lastly, the body inside of it. And if we add one element, we can add a button like so, and we can highlight all of the boundaries of these objects or elements on the page. And if we now click on the page, we can click the button. Naturally, that element becomes our target of the event. Why? Because in this case, it's the innermost clicked element on the page. What that means is that if I click outside, we will now have assigned the body as the target of our event. The thing is, we can actually continue on by assigning, for instance, a margin top to the body, and this is absurd, but to prove the limits of this system, this is possible. In this case, we will have assigned the HTML element as the target of our event. The thing is, this is where it stops. You cannot move beyond this point. Why is that? It's because we have now left what we call the presentational layers or boundaries of our web page. In this case, that corresponds with the clickable area on the web page. But that begs the question, what are the other objects in this hierarchy? They are what we call abstractional layers of the DOM that are grouped for logical reasons, and they are very much included in the actual system that we soon will be discussing. Hence, they are important. If we continue on with the example of clicking the button, we can do it like so. We can see that the button has become the target, but we also have something to the right here called event. What is this? The event is an object that holds all information about the event that was just fired. And the thing to know is that this event object is crucial and plays a very important role in the system that we will now be discussing. And this system is known as event propagation, because once we have a target and an event object, a process will start known as event propagation. And what this process entails is that it will move through 3 different phases as follows: capturing, at target, and bubbling. I view them as walking in, turning around, and walking out the same way we walked in. So with this new information, we can now go back to the previous example of clicking the button. We have the event target as well as the event object, and this is the point where the event propagation system starts by entering the capturing phase or the walking in phase. And we will see that the event object will pass through every single element before reaching the target, whereby it will transition to another phase called the at target phase or the turning around phase. Here, it will move past, but not further on, the event target object, after which it will transition to the walking out phase or the bubbling phase. And it will walk out the same way it walked in. After this, the event propagation system is completed. The event object will, during the event propagation system that we just illustrated, visit every element in what I call the affected hierarchy. This is also known as the event propagation path. And we can illustrate this by looking at slightly more complex HTML. We can see that we can still click the button and produce the exact same affected hierarchy that we had in our example. But the thing is, if we click elsewhere, for instance on the paragraph, our button element is not included anymore in this path. The same is true for the list item click or the unordered list click. Even if we click on the body itself, the button is not included. What makes up the rules of which element is included in this affected hierarchy? Well, the element needs to be part of one or two criteria. The first one is it has to be an ancestor to the target. And if it is, it will be included by being visited twice by the event object, once on the way in and once on the way out. The other criteria is that if it's not an ancestor, it has to be the event target itself. Those are the types of elements that will be included in this path. And the crucial thing to know is that ancestors visited twice, but the target is only visited once. Well, that begs the natural next question, which is, why do these visits even happen? Well, the event object visits the ancestors as well as the target to see if there is an event listener function attached to those elements, because if there is, it will be invoked as part of that visit. Naturally, we will proceed by attaching an event listener function to one of our elements, in this case our button element. And we can do this by writing as follows. For this element, I want to register a click listener. Given this written code, if we now click on the button, we will once again enter the event propagation system. It will enter the walking in phase, walk in, transition to the at target phase where it turns around, but during the turnaround, this function is found and invoked. After this, it transitions to the walking out phase or the bubbling phase, where it walks out the same way it walked in. After this point, once again, the event propagation system is done. We can make this example a little bit more involved by adding event listener functions to every single element in the affected hierarchy, not just the event target. And we can do this by adding the event listener to different references of these ancestors. And if we now click the button, which will become the target like before, during the event propagation system, while walking in, we will see that these functions are actually not invoked as expected. Once we reach the target like before, we can see that this event listener function is invoked as expected. And on the way out during the bubbling phase, we will see that these attached listeners are actually invoked as expected. Why is this the case? Well, a decision needs to be made every single time you attach an event listener function to an element. By default, the so-called listening mode of bubbling will be used if you write what we just did. This means that the attached function will be invoked during the bubbling or the walking out phase. This is by far the most common, and I've never done anything else personally. But you can change it to capturing or walking in by writing a third parameter to the add event listener function, representing whether or not you want to use capture. And worth noting is that the turnaround is always included, and this is probably why you never hear anyone talk about this phase at all. We can look at the same DOM as before, and if we attach a listener to our body and click the button, the body will become the ancestor, right? This listener will be invoked during the bubbling phase, once again because we attached it in the default listening mode of bubbling. If we click the body instead, but leave the code intact, it will now be invoked during the at target phase, illustrating the point of it being included no matter what. If we click on the HTML element instead, once again leaving the code intact, this listener will never be invoked. Why? Because it lives beyond the actual target of the event. It would make no sense for that listener to be invoked in this particular scenario. One last important point to make is that your code cannot predict which element becomes the target of any given event, only for which element to listen. Why is that? Well, it's up to your user to decide, in this case, where he or she clicks. And that's it for the first part of this small video series on event propagation. In the next one, we will start looking at how you can leverage this powerful concept in your day-to-day work as a developer. Thanks for watching.